Right, we're looking at rules of differentiation in this video. So just to refresh what a derivative is, we have a function like this one we looked at last time, x squared, and we saw last time that the derivative was 2x. So that thing there is called the derivative. It means slope of the function, and sometimes we write it as dy over dx, just like that. So for example, at x is 4, the slope would equal f dash of 4. So this would be, well, 2 times x is a formula, so that's 2 times 4, which is 8. So if we look at this graph where x is 4, it's sloping up pretty steep, and the slope is about 8. Whereas if you look at something a bit further back, like 1, the slope is much less steep. So m is 2 there. Okay, 2 times 1 is 2. So we've got some rules for derivatives. We don't have to do first principles every time, thankfully. And the main big rule we use is this one here. So the way that it applies to this formula here is if we look at f of x is x squared, the derivative, we take the 2 and we move it out the front. That's the first thing we do. So we're going to get 2x, and the new power is 1 less than the old power. So 2x to the 1, we can simplify that just down to 2x. So this works in general for any powers of x. So for example, if f of x is x cubed, f dash of x will equal 3 out the front, x, and the new power is 1 less than the old one. Now, if we want this one here, y, so we've got to write the derivative like dy dx. The 5 will come out the front, and it gets times with the 3, so that's 15x to the 4. There's another rule for if we've got ax. So ax goes to a there. So minus 2x just goes to minus 2. And the plus 1, so that's just a constant on the end, so that goes away. So the derivative just looks like this, and that's totally finished. So I'll give you just a few really common derivatives. So this table would look like this. Hopefully you can see what's happening. The numbers coming out the front and the power is dropping by 1. If we have functions like this, the numbers times out the front, so that would be 10x to the power of 1. That one would be 6x squared. That would be minus 12x to the 3. There's 4 times minus 3 out the front. And this one would be minus 5x to the 4. If we have things like this, notice all these numbers are just times by x. So we're left with the actual number itself. 2, 5, 103, negative 10, 1, minus 1.234. Be really careful because that one's a 1x there. And I'm hoping that makes sense, because if I look at the function y equals 2x, this is a straight line with a y-intercept of 0 and a slope of 2. So I'm hoping we can agree that the derivative of that line is 2. That means the slope. And it's at any point, so it doesn't matter what x is. Now here I've just got all constant numbers. So any derivatives will be 0. And again, if we look at that top one, and I just look at y is 2, then that line just has a height of 2. And if I pick any point on that line at all, the slope will be 0. Okay, it kind of looks like it curves up. That's just my bad drawing skills. We can do functions where they're added together. So x squared plus x cubed, you just differentiate each bit. So just like that. x4 goes to 4x cubed, and minus 5x just goes to minus 5. That would be 2x plus 3 as the derivative there. This one, the 1 goes away, and you're left with minus 4x. So you get 2 times 2 out the front, and then the power drops to a 1. This one here, the 3 goes away, and we're going to get minus 20x to the 4. So that would be the 5 times 4 out there. And then we're going to get plus 4x, just like that. Okay, that's good. And then we can differentiate some more types of functions. So these are a little bit more advanced, but if we have 1 over x squared, how do we get the derivative? Now, this one's a bit weird because we can't just differentiate it straight away. But what I can say is that f of x equals, and then I can use my index law to rewrite it, this one in particular. So we're going to go x to the power of minus 2. That's the original function. And so the derivative will be minus 2 times x. So the minus 2 comes out the front. And the new power is 1 less. So that's actually going to go to minus 3 there. If you want, you can write this as minus 2 over x cubed. That's the derivative. Last one we like to do a square root of x. So we can rewrite f of x using an index law. So square root of x is x to the power of a half. So that's this index law here. And then we can bring the power out the front. So f dash of x is a half x to the minus a half. Now this new power is 1 less than the old one. So essentially I need to go a half take 1 there to get that power. There's a couple of ways you can think about this. First of all, you can just do it on your calculator if you're really not comfortable with fractions. So a half take 1 is minus a half. So that's how I got the new power there. One way that you can think about it, probably the more formal way to think about it, is a half take 1 is a half take 2 halves. So that is 1 take 2 over 2. That's minus a half. You might want to think of it as a half take 1 is 0.5 take 1. And if you like decimal numbers, you get minus 0.5. Or you can think of it on a number line. So 0, 1, and minus 1. I'm at a half and I want to take away 1. So we get 2 minus a half. So whatever way you like thinking about it, your new power is minus a half. That's the point. Now let's think about what this does. So this is a half x to the minus a half. The negative power puts it underneath. So it could look like this. And x to the half is the square root of x. So those are some common derivatives. That's pretty much all the rules we'll learn this year. And then there are some rules to differentiate stuff later on that we'll learn. Just be aware, if you ever get something like x times x squared plus 1, you can't just differentiate each bit. So yeah, the derivative, if you said it was 1 times 2x, that would be wrong. So it only works to split it up with plussing, not timesing.